Everybody. We're going to move to our next session, as Carson said, where we'll hear from former researchers who are thinking about different approaches to targeting aid. So first up, we have Brian Dillon, who is an assistant professor of development economics and applied econometrics at Cornell University and a SIGA affiliate. So Brian studies agricultural development, seasonality, market integration, labor, and the emergence of new markets, primarily in sub-Saharan Africa. And today he'll present work from Malawi on targeting food aid. So take it away, Brian.
Wonderful. So I'm excited to be here presenting the work of this great team, Paul, Aaron, Hope, Twigwe, Dana, Joanna, and some others who've contributed over time. This talk we called Food Aid Targeting in a Fast Changing World. So the fast changing here is not a generic reference to modern life. This is actually going to be about a specific feature of food security dynamics that you'll see as I get into the evidence. So to fix ideas, let me just start by setting some common understanding of what is food insecurity. So we measure food insecurity using indexes that capture choices and behaviors that are connected to the idea of inadequate access to food. So this starts with things like worrying about food, and then it progresses through increasingly serious forms of food inadequacy, from eating less variety, reducing volume, not having food stores, going to bed hungry, and even in its most severe circumstances, going a day and a night without food. All right, so a household is designated as food insecure if an index based on these and some other related behaviors is above a certain threshold. So I'm not going to get into some of those definitional issues today. There are many, but just to get a sense of the severity, there are about 880 million food insecure people in the world at this moment, according to the World Food Program. So there are some fundamental challenges to identifying and distributing aid to food insecure households. It's challenging for many reasons, but the one I'll focus on today is rooted in the dynamics. Right? So food security status changes, and it changes differently for different households, some of whom experience chronic food insecurity, while others have acute episodes, usually related to shocks of some kind. So here I'm depicting these two stylized households. The orange household differs from the green household in a number of ways that I've tried to depict with these icons. So think of it as having less land, maybe less livestock, a simpler dwelling, more people. All right, so the orange household here is chronically food insecure. Notice that the severity of the household's food insecurity changes substantially. So how far it is from this threshold for food security, even though its binary classification as secure or insecure does not change. Also notice that it does have this brief period of food security, followed by some shock that returns it to a food insecure status. The green household, in contrast, is food secure for a period of time. It experiences a shock, becomes food insecure, recovers, and experiences another shock. The other feature of this figure that's worth noting is that I've drawn it such that the first shock here is correlated. The orange and the green households move together. So this could be a drought, civil conflict, some kind of shared common event which affects these households at the same time. The second shock to the green household here is idiosyncratic. It seems to be related to possibly an illness or crop failure or something about that household. Okay, so if food security is dynamic and the goal is to distribute food aid in an efficient manner for households that may be chronic, may be acute, and with dynamics that we don't have a good grasp on, our fundamental question is, how should we monitor? What should we be doing? How can we use evidence to design a monitoring system that allows for efficient targeting? So this is especially important when aid can take months to arrive. The institutions that do this are very good at what they do, but even for an organization like Catholic Relief Services, our partner, ramping up aid and targeting it into new areas where they're not already programming can take some time. So constantly surveilling everywhere is surely inefficient. Remotely sensed data can probably aid us in this problem, but exactly how it compares to on-the-ground data is an open question. We're going to try to get at some of those questions in our study. So what do we do?
Sorry to just interrupt for 1 second. If you have a Zoom open in the top right corner of your screen, a big box, I think it might be blocking part of the slide.
Oh no, I'm sorry about that. Is that better?
Yes, that's perfect. Thank you so much.
All right, thanks, Anya. That was you guys. Okay. So I can't see anyone now, but that's fine. So what's our approach? We want to understand how to optimally monitor when food security is dynamic. So the first thing we need to do is measure those dynamics. So we're going to closely track a sample of households in Malawi over a long period of time. Because we're going to see food security status for 3+ years, we can then start to ask questions like, what are the best predictors of food insecurity today? And we're going to play off a few options. All right, the first are recent data on food security outcomes. So if you were food insecure 1 month, 2 months, 3 months ago, what does that tell us about your food security status today? Think about that as capturing the persistence of shocks. We're going to compare that to the predictive power of past data on assets, wealth, land holdings. These are like the proxy means tests that others have talked about today in some of the other talks. And then we're also going to look at the performance of remotely sensed data, such as greenness indices and weather variables. Okay, so high frequency food security monitoring in Malawi. This project is called the MIRA project. It's been running since 2018. This is Malawi in red on the right here. And then within Malawi, we're focused in the 3 southernmost districts, Blantyre Rural, Chikwawa, and Nsanje. More than 2,200 households are participating. Each year we measure things that might be components of a proxy means test, like assets, land holdings, other things. And we measure food security every month. This is directly working with Catholic Relief Services. And so the idea here was to do this in a way that would inform their monitoring and targeting activities here and eventually elsewhere. First, let's just take a couple of snapshots from the data. So here we're plotting the household hunger scale. That's going to be our main measure of food insecurity on the left. And that ranges from 0 to 6. And 3 is the gray dashed line. That's a common policy cutoff if you're trying to classify households as needing intervention or not. All right, so these are just 3 example households out of the 2,200. Household 1 here is almost never food insecure. They have one brief episode here. You do see some intertemporal fluctuations in the severity of their food insecurity. So there are times when they're worried about food, they may be reducing meals or skipping meals. Household 2 is moving in and out as far as the binary classification is concerned. But again, there's wide variation in their experience over time. Household 3 is always food insecure. And in the last year of our data here, running up into 2 months ago, into August of this year, you're seeing that this household is severely food insecure. This is a household that is struggling to meet the basic needs of all household members. So these are the empirical analogs of that stylized figure that I showed you before. And the experiences of these 3 households are also reflected in some of the more aggregate statistics. So if we just look at a histogram for a 12-month period of the number of months spent in food insecurity, all right, what you see here, this is actually a larger sample that involves some other households that we've expanded with MIRA, but the broad features of the sample are the same. We're focused on a high need area. So the majority of households here are food insecure for half the year or more. All right, but there's wide variation in their experience. And what this figure does not show is that there's significant variation in the severity of food insecurity across months, even for households that are always or almost always classified as food insecure. All right, with that as the backdrop, let's get into our core findings in terms of how these models perform. All right, this figure contains all of the main results I'll discuss today. So let me walk through it in steps. The vertical axis on the left, this is a normalized function of the root mean square error. So really, this just means higher values indicate worse performance in modeling the household hunger scale. And notice here, we're trying to predict the actual value from 0 to 6, not just a binary classifier of food insecure or not food insecure. Along the horizontal axis, we're indicating the different models and the data inputs that we use. All right, so let's look through how those compare. The blue dot here, by the way, is a benchmark case based on sort of using the household's average over all periods. This would not be available in any circumstance other than something like MIRA. So for us, it's purely a benchmark. It's not a policy option in most contexts. Okay, and then lastly, I'm not going to talk more about methods or statistical testing, but all these estimates use best practices for machine learning in terms of training on one sample and testing on another. And if I talk about differences here, they're statistically meaningful. Okay, so first, these 3 models at top left, these are all based on something like a proxy means test using data collected in 2018 at our baseline. So Emily referred earlier to the notion that proxy means tests might have something like an expiration date. You measure them at one point and then you move forward through time, and it's an open question how well they perform years later. Well, in our data, on average, a proxy means test from the beginning of this 3.5-year period performs about as well as just knowing households' food security status from 5 months ago or older. Okay, so these PMTs, they're not doing badly, but if we knew a household's food security status more recently than 5 months ago, then actually we can do a better job of predicting their food security today than if we know lots about them from a baseline survey and we estimate models using a wide variety of techniques. Okay, second, if we use remotely sensed data, so machine learning applied only to remotely sensed weather variables. This performs a bit better than the PMTs and the older food security measures, except you have to remember that we trained this model on 3+ years of data. And I didn't plot them here, but if we had trained this on only 1 year or 2 years of data, quite intuitively, you'd see that the performance is worse as you use fewer and fewer years of data to train this model. So what that suggests is that while remotely sensed data might be useful in a setting where you already have good data, for us, it doesn't do as well unless we have many years to train it on. The clearly best performers are food security measures from 1 to 3 months ago. The suggestion here is that there's a lot of persistence in shocks, and that for these households, knowing how they were doing 1 period ago, 2 periods ago, 3 periods ago, does about as well as if we knew their average status over the entire 3.5 years. So then, what does this suggest? If what we're telling you is that things change enough that you really need to know what's going on in the last few months to do the best job possible of forecasting, does that suggest that we need to constantly monitor? So none of these models, first of all, is doing a great job of forecasting food insecurity. These RMSEs are not small. And the implication there is that even if I could measure households today, if I showed up a month later to deliver food aid, a substantial number of households would have changed their status in terms of the behaviors associated with household hunger. The other is the differences in the statistical performance here are not equivalent to differences in policy recommendations. So one of the things we're doing in our ongoing work is translating these statistics here into actual policy decisions. So what would CRS do with these data? Because that dampens some of the differences between the model performance. The third point is that collecting this high frequency data is costly. So the last thing I want to talk about today is some of our more recent activities where we're trying to find creative ways to bring down the costs. So motivated by the fact that knowing what's going on right now, a month ago, 2 months ago, is very helpful, or at least relatively helpful. Can we do that in a more efficient way than sending out expensive teams to measure food security? So this approach we call phone tree sampling, and this was actually developed during COVID in Zambia with my colleagues at the International Growth Center, and we've merged the two projects to try to apply it to food security. When you think about measuring food security, we have these various options. We could do traditional in-person surveys, have these panels settings like Mira, where we watch people for a long period of time, phone surveys based on random digit dialing, remotely sensed data would have to be trained on something. The method we're using, we call phone tree sampling. The basic idea is just that we reach out to some seeds, people who might have contacts with a target population, and we ask them to suggest potential respondents. We call those respondents, we survey them, and then we request referrals for additional respondents. We work our way through the tree, and we do it in a stratified way where referrals involve not just asking for anyone, but asking for people in a particular area with particular characteristics, knowing that will lower our success rate for referrals, but allowing us to ideally target our survey in an area where maybe there's high needs, maybe there's civil conflict, there's an infectious disease pandemic that's preventing us from sending a team out, or we don't want to dedicate tens of thousands of dollars everywhere to constantly sending out in-person teams. And we think that we can do it at lower cost using a phone tree. So what we're currently doing in Malawi, and I don't have results to show you, we're just getting this off the ground, is to see what happens if we try to use a phone tree survey in the same areas where we have the Mira data. And we want to know, can we sort of burrow in using a phone tree from Lilongwe, from the capital, from CRS offices here, to quickly and cheaply collect food security data that is as accurate as the Mira data, or where we can at least estimate, see the trade-offs and understand the cost differences. And so hopefully capture some of these high frequency changes in food security more at much lower cost.
Brian,
Okay, so that's our team's
you
work.
have like a minute left.
Oh, that's it actually, Christina.
Okay, great. Perfect timing.
And say thanks very much. And yeah, I'm looking forward to your questions and feedback and appreciate your attention.
Excellent. I think we can maybe take one question then and we'll have to move on. And you can always answer them in the Q&A box. I believe we have a question from Hope asking, are there domains of welfare in which the most deprived are improving, gaining that you don't have measures for, but you'd like to be able to assess?
That's an interesting question. Um, I don't have an immediate response because we're so focused on what we do have that asking what are the measures. So there's many things we don't have. Let me put it that way. If we think about things like labor market, participation, income dynamics, even poverty and consumption dynamics, MIRA does not measure that stuff in high frequency. And so I think the best answer to your question is that there could be a lot of other ways of understanding the well-being of these households that we might care about in high frequency and that I would be interested in as a researcher, that these data don't allow us to see. And so I could imagine wanting to fold some of those into similar efforts, but we're so focused on food security with the MIRA data that we can't answer a lot of those other questions in high frequency.
Great, thank you. So there are a couple extra questions for you in the Q&A, and maybe you could answer them in there, but we're going to have to move on for now. But thank you so much for presenting. So next up, we'll have Carly Trackman, who is a sixth-year PhD candidate in agricultural and resource economics at UC Berkeley. Her focus is on development economics, agricultural economics, and behavioral econ, including topics like program targeting, technology adoption, and agricultural value chains. So today, Carly will present her job market paper on the limitations of community-based targeting. And a quick reminder to our speakers that you have 15 minutes total for your presentation. So Carly, I'll pass it over to you.
Thanks, Christina. Let me just share this very quickly. Okay, and minimize. Hopefully you can see now. Okay, thank you so much for having me today. I'm really excited to talk to everyone about this work, about community-based targeting, which actually the last presentation left us with a great segue to that point. And this is joint work with two colleagues, Yudhistira Pramana and Gumilang Sahadewo, who are both at Universitas Gadjah Mada in Central Java, Indonesia. No? There we go. Okay. So a question that we've been asking in the last few presentations essentially is, this question of targeting, about how do we reach households that are currently in acute distress? And as we just discussed, some traditional methods like the proxy means test generally rely on observing ownership of assets and durable goods or other sort of fixed demographic characteristics to predict households' current welfare. And of course, these methods are improving as we see, but sort of a key issue is that they may not capture these types of shocks that households experience, such as bad harvest, death of a household earner, etc. And so, sort of these acute shocks where households may not, necessarily, change their roof material, for example, in response. We might just see them, sort of start limiting meals or things like that, which, again, as we just discussed, might be tricky to observe. So a potential opportunity of an alternative method is thinking, what if instead of as an outsider trying to sort of observe what's happening to households, if instead we just ask individuals in the local community? And so the idea behind that is that I might know if, neighbors or people that I'm friends with have recently experienced one of these negative shocks. And so they might be able to sort of provide that information to the policymaker to target the program instead of trying to sort of collect other costly information. So that brings us to this idea of the method of community-based targeting. And the idea behind community-based targeting is essentially that there's some sort of formal collection of welfare information from local individuals in a community, where those individuals generally know that whoever is sort of identified as the poorest or the neediest in these information gathering exercises will receive some sort of social benefits. And so there's an example in this picture of such an exercise that is relevant for the work that we do here in Central Java. And specifically, this is a type of community-based targeting called a participatory welfare method, participatory welfare ranking, where individuals in a community are gathered at a meeting. And first what they do is sort of together brainstorm what it means to be poor in their specific context. And you can see this little poster sort of on the wall where they've done that. And then afterwards, there's essentially this exercise where they rank all of the households locally from poorest to richest. And you can see that going on here with the little clothesline with note cards. And so there's a few things that I want to point out about these community-based methods that I think are important. So one thing is that they're certainly, in most cases, much cheaper than some of these more data-intensive methods. So collecting surveys we know is expensive. Collecting, high-frequency satellite data is probably also quite expensive. And so, as you can probably guess from this picture, these methods tend to be much cheaper. So that's a potential benefit to keep in mind. Another way that you might also want to make them even cheaper is, instead of trying to get all of these community members together in one setting at the same time, is just to ask, some small subset of key informants, so like local leaders, for example. However, the idea behind having this big meeting is sort of twofold. So one is that if you ask a lot of people who all have different sets of information, we might actually get better information by, combining the information all of those individuals have separately. And second, another key concern that sometimes arises in the community-based targeting literature is, what if people sort of try to game the system? What if I basically say that my friend or my family member is poor even when they're not, just so that they get the benefits because I have a preference over them getting the benefits? And so there's this idea that if we do this at a meeting where there's other people there might be some sort of checks and balances kind of exerted by the community, where it's harder to do some of those sort of preference-based things. Now, a lot of research about community-based targeting has really tried to, focus on, how are people trying to, strategically manipulate these outcomes, which is an important question. But there's actually not much we know about sort of what the information that individuals actually have and provide is. So there's sort of this assumption that neighbors can well observe, if somebody else has experienced a shock or is skipping meals this week, but we don't actually have any, a lot of evidence that that's true. So in the research here, we're asking three main questions, and I like a nice diagram, so hopefully you will bear with me through the silly smiley faces. But the first question is just, what information do individuals actually know? And so specifically, we want to know whether this information is sort of this current up-to-date information that we might not capture with a proxy means test. So is there additional information that we get from, instead of just looking at, somebody's housing quality, that their neighbor can provide, like if that household has recently faced a bad harvest or is food insecure? Then, given we understand what information individuals have, the next question is, what information do they actually report in a targeting exercise? So, when I actually ask people, for the purpose of whoever you note as poorest is going to receive this transfer, what information are you going to give me out of what you have? And then the third question is, when we get these people together in a meeting, what is the information that they then report in this joint context together? So how are we going to answer these questions? So I've put it here sort of next to the question. For getting at community information, we ask individual community members to provide us information, and specifically we ask them about various specific welfare benchmarks. So some of these benchmarks are things that we think are probably more dynamic and changing over time in response to shocks that households face. So things like per capita consumption, and generally like household neediness. And then some of these things that we ask them about are the sort of less dynamic things we capture under these more standard methods, like about asset ownership. And specifically here, in order to try to make sure that individuals are providing us with correct information, sort of the best information that they know, we actually incentivize these participants themselves to give us correct answers. So we give them some payments based on whether their data, whether the information they provide closely matches the same information we collect in a household survey. Then, to understand which of this information individuals sort of pick to use when they do a targeting exercise, we then ask individuals to actually do a targeting exercise by themselves, where they essentially have to note certain households as poor, knowing that some of the households that they note as poor will receive an additional social benefit, which in our case is a cash transfer. And then third, we actually have some community meetings where we ask these individuals to complete a similar targeting exercise, but do it together. And I'm happy to go a little bit more into the details of the methods for people that are interested, but essentially it involves ranking households from poorest to richest in a variety of different ways under these different sort of incentive schemes that I've noted here. So the setting here is Central Java, and specifically in the Purworejo Regency of Central Java. So the participants are 300 families in 10 Rukun Tetanggas, or Rukun Tetangga is actually the plural. And each of these have about 50 to 70 households you can think of. So they are quite close-knit communities, and in practice, people do report knowing other people very well in these settings. These households are mostly agricultural, farming rice on small plots. They're relatively poor. You can think about per capita food expenditures being about $16 a week in terms of purchasing power parity. And generally, these are quite socially homogenous communities. So most of our participants are Muslim, are Javanese, they speak Javanese, and they are very sort of active in various community organizations. Now, why do we choose this setting? There are certainly a lot of places where we might think community-based targeting would be useful. We specifically look at Central Java just because a lot of the evidence that we already have in the literature about targeting comes from the Indonesian setting. So this helps us sort of build on to what is already known and contextualize other findings as well. So what do we find? So first, in terms of the information individuals actually have when we incentivize them to provide us with the correct information, we find that they really don't have this sort of up-to-date dynamic information that we thought they might. So specifically, participants do a pretty poor job at identifying those households that are currently have low consumption levels or are currently very needy and sort of facing this acute neediness right now. Additionally, we also ask households directly participants to directly report on other households. And we ask them, did this household recently face a shock? Did they have, a bad harvest or have somebody, sick in their household? And we find that even when we ask them sort of directly about these yes or no questions, participants also can't sort of accurately report these things. And essentially, they're equally likely to report that a household that did not have any of these shocks versus did have a shock, they're sort of equally likely to report that said households have a shock. So there sort of is no gain in targeting accuracy. And additionally, many respondents actually refuse to answer the question because they don't know. It's about half of all respondents. So what information do community members have? It seems like they do have some information about asset ownership, and especially land ownership. So these types of things that we try to observe through proxy means testing or other sort of satellite methods are actually sort of the same things that are observed by households. What information do they use when they're actually doing a targeting exercise? Well, sort of in line with this being the information that they have and feel confident about, community members generally use information about asset ownership and other sort of demographic characteristics that don't frequently change in identifying which of their poor neighbors should receive social benefits. So we see this both by comparing how close their rankings based on assets and consumption and things are to the ones they provide under a targeting exercise, but we also ask them just sort of qualitatively to explain their targeting decisions. And when they do that, most of our participants note things like differences in land ownership as sort of drivers behind who they think is poorest. Additionally, we actually don't find much evidence, at least in the context of our experiment, that people are trying to disproportionately give these transfers to their friends and family who aren't actually poor. We have a few tests of this, but essentially we just don't find a lot of evidence of this here. Not to say that that might not be the case in other settings, but that doesn't seem to be driving our results. And then the third thing we find, also perhaps surprisingly, is that individual reports are very similar to group meeting reports, and they don't look sort of more accurate on any specific welfare benchmark. So when we look at community rankings versus sort of individual rankings on average, we're not gaining any sort of more accuracy in terms of better matching our survey data on consumption, neediness, or asset ownership. And notably, you'll see one of the sort of brainstorming sheets defining poverty is here on the right. And you can see things like assets, mobile phones, this means land, house. These are sort of the same things that are coming up when individuals make a targeting decision as a community. They're also trying to think about these sort of very observable assets. So to just sort of summarize all that, it seems like unlike what we might have thought about households having, information on who's recently fallen on hard times or experienced a shock, it seems that what households actually do know are these sort of things about asset ownership, about land ownership, housing quality, which we think that we might be able to reasonably capture with survey methods that we currently have. And additionally, this seems to be the information that they're using when they're targeting transfers. And then thirdly, when we go to the community meeting setting versus the individual, we don't see sort of more accurate or more up-to-date information being shared.
Carly, I'm
So
just
what does this mean?
that you're almost at time here.
Okay.
At time.
I promise I won't.
Sure.
So basically, we find that community-based targeting is not always more appropriate for targeting current welfare than other methods, but it still may be useful in sort of targeting these longer-term poverty things, in that it captures very similar information to what we would get using proxy means tests or these other type of methods, but may actually be cheaper. But the one caveat that I do think we should keep in mind is that this is one specific setting and that these results may not hold in other places. So specifically, Indonesians tend to be quite reputation conscious and hence may not sort of share information on the hardships they're facing with their neighbors. And so that sort of might, limit information sharing. But then on the other hand, these communities are very socially homogenous. And so in some sense, that might allow them to share more information than in places where there are sort of stronger divisions or castes within society. So thank you very much. I appreciate your time and I'm finished. Thank you.
Great, thanks so much, Carly. There are some questions from Layla in the Q&A. I think maybe we could take one of them.
Okay. Let's see. So how do we include socially marginalized individuals in these programs and make sure they're captured in our original seed? Yeah, so that's a great question. Like I said, I can't really get at that too much in this specific project just because these are very homogenous communities, number one. And number two, this is actually coming from sort of like, our initial lists are coming from a village census. So in places where there actually is a village census that's relatively accurate, I guess that might be one way to get around that. But I do think that that is something that we need to think about more carefully, especially in settings where populations are sort of more heterogeneous and just sort of trying to figure out that or sort of ask as many people as we can.
Great, thank you. And if you'd like to, you can continue to answer questions in the Q&A box below. Great, so we will now be moving on to our next presenter, Riyazul Chowdhury, who is a PhD candidate in agricultural and consumer economics at the University of Illinois, Urbana-Champaign. He works on topics in behavioral health economics and income and growth of microenterprises. So previously, he has worked as a senior research associate at BRAC International in East Africa, so that's South Sudan, Uganda, and Tanzania. And he obtained his MBA from the University of Dhaka, Bangladesh. So Riyazul will talk to us today about improved targeting in BRAC's Targeting the Ultra Poor graduation model. So I'll hand it over to you, Riyazul.
Hi, thank you. Can you hear me? Hello?
Hello?
Yes, we can hear you.
Yep.
Mhm.
Oh, yes, great.
And also
Thank you.
I'll throw in there too, also Riyazul was a fellow at SIGA. So just wanted to throw that important tidbit out there. Go
Okay,
ahead.
thank you, Christina, and hello, everyone. Today, I'm going to talk about a paper that is related to improved targeting. In this paper, my co-authors and I try to answer a question where when enrolled to an anti-poverty program, who among the poor benefit from the program and who do not. So to answer this question, we look into a anti-poverty program, which is called the Ultra Poor Graduation Model. This model has been found very successful in poverty reduction in several developing countries. The program involves identifying the extreme poor households from communities and then giving them a group of support, and that support includes giving them a transfer of productive asset, mostly livestock, training them on how to maintain those livestock, and giving them consumption support for almost 2 years. And the purpose of all this support is to create a sustainable livelihood for these extreme poor households and help them to get rid of poverty. So this program was first designed and implemented by BRAC, a Bangladeshi NGO, And then this program has been adopted by many other NGOs in different countries. Now it is being implemented in 75 countries. So there are several studies, like high quality randomized trial studies, that assess the impact of this program in different continents. And these studies found high impact of this program. But this program, this after graduation model is very expensive, at least compared to the other alternative approaches of poverty reduction, like conditional or unconditional cash transfer program. This is expensive because this program involves a group of support services directed to the ultra poor households. So to make things worse, existing studies also show that this ultra poor graduation model, its treatment effect is highly heterogeneous. That means within the beneficiaries, within this program participants, there are a group of people who benefit a lot from their participation in the program, and there are others who do not benefit, which harms the cost effectiveness of this program. And one way we can improve the cost effectiveness of this program is to identify the people or the participants who do not benefit from this program. And then if you can customize the interventions to fit their needs, to help them better, that would improve the cost effectiveness of the program. But finding those who do not benefit from an anti-poverty program is a bit challenging. It is methodologically challenging because traditional econometric models like ordinary least square model, those are not very efficient in identifying the groups of participants who do not benefit from their participation from an anti-poverty program, because ordinary least square model requires you to ex ante decide on which variables there might be some heterogeneity, and then you look for those variables to find heterogeneity in the treatment effect. And when you do that, you place yourself in the risk of overfitting the estimations. And also, the ordinary least square model doesn't allow you to use the rich set of baseline variables that you might have at your hand. So you are basically leaving other potential sources of treatment effect heterogeneity unexplored. So in this paper, we use recently developed machine learning methods that allow us to use rich set of baseline variables to identify among the participants who benefit a lot and who do not benefit. And once we identify those groups, we can characterize them by their baseline characteristics so that we know who among the participants are benefiting and who are not being able to take advantage of the program. So our data come from a cluster randomized trial by Oriana Bandiera and her colleagues who evaluated an graduation model implemented by BRAC in Bangladesh. This was a cluster randomized trial where they targeted 40 BRAC branch offices, and half of these BRAC branch offices was randomly assigned to treatment group and the other half was assigned to control group. From these 40 branch offices, they have identified more than 5,000 extreme poor households. And of these 5,000 extreme poor households, 3,000 or more than 3,000 of these households were in the treatment clusters or treatment branch offices, and the others are in the control branch offices. So once they identified these, so what then BRAC did is, from the treatment clusters or treatment branch offices, they identified the adult women from some of these ultra poor households, and then those women received a grant transfer of productive asset, mostly livestock, from BRAC, and then they received some training on how to maintain that livestock. And for 2 years, these households also received some monthly basis consumption support from BRAC. And BRAC field staff also visit them on regular basis for 2 years to monitor their progress. So Bandiera and her colleagues, they had 3 rounds of survey. The baseline was done in 2007. Then there was a follow-up survey in 2009. And then in 2011, they did an endline survey. In this paper, we are using the baseline survey data and the endline survey data for our purpose. And for our main analysis, we limit our focus on only two outcomes, that's per capita assets and per capita expenditures, household expenditures. But we also complement our analysis by looking at some other additional outcomes. So as I said before, we use recently developed machine learning methods that enables us to estimate the treatment effect for each household. This is something that ordinary least square methods cannot do. So these machine learning methods allow us to estimate the treatment effect for each household. And based on those estimated treatment effect, we can see whether there is a large degree of treatment effect heterogeneity. That means we can identify among those program participants if there are a group of participants who are benefiting a lot and there are others who are not benefiting at all. So once we identify those groups who are benefiting a lot versus the who are not benefiting at all, we can characterize them by their baseline characteristics to identify who are those households who are not taking advantage of this program. So when our findings, when we look at the overall impact of the program on these two outcomes, like asset accumulation and household expenditure, we found that the graduation model has increased the asset accumulation among the program participants by more than 250%, and the graduation model increased their per capita expenditure by more than 14%. These impacts are large in size, but these are consistent with the existing studies that reported similar magnitude of important effect of this program. And when I look at the treatment effect heterogeneity, we did find, and that is also consistent with the existing literature, we also find that on the asset accumulation outcome, there are a group of people who could accumulate a lot of assets in the 4 years of the program. And there are some other group of people, participants, who did not accumulate much assets. So basically, they didn't have any impact from their participation in this program. We also find a similar results for the consumption outcome, but for the consumption, the estimation from the consumption outcome was a bit noisy, and the treatment effect heterogeneity that we detected on the consumption expenditure was not that significant. To give you a visual presentation of what we did to identify those groups who benefited by most and least, so we divided our sample, all these households, into 5 groups based on their estimated treatment effect. So group 5 here, for example, this left panel of this box plot distribution, the group, this is the beneficiaries on the wealth outcome, and group 5 on this figure is the group of households who could accumulate most assets, and group 1 are the households who could not accumulate or who gained from the program. So if you look at the distance between this group 1 and group 5, these are quite large, and we see a similar trend on the consumption outcome. But the problem is the estimations on the consumption outcome is more noisy. So the degree of heterogeneity we detected on this consumption outcome was not very significant. But then what this graph helps us to understand is to see the existence of households or the program beneficiaries who benefited and who did not. Then the question is, who are those households? And to answer these questions, what kind of households benefited from the program and what kind of households did not, we have to look at their baseline characteristics. But in our model, we used more than 50 baseline characteristics, and it would not make sense to look at all those variables and define those households. So what we did here, we identified the 15 most important variables that were found important in our model estimations. So if you look at these 15 variables, and in this graph, we have plotted these by their importance. So the most important variable was their baseline per capita wealth level and their women's their participation in decision making, in household decision making. So if you look at this 15 important variables, you can categorize them into 3 groups. You can categorize them at the beneficiary level households, household level, beneficiary level characteristics, household level characteristics, and community level characteristics. And then in this slide, I'm presenting a graph where we took the top gainers and the bottom gainers, like the households that benefited most and the households that benefited least. And then we are looking whether these 2 groups differ from each other on the baseline characteristics, the characteristics that we identified on the previous slide, the 15 most important.
Riyajul, I'm going to give you a little nudge to wrap up pretty soon.
Sure.
Thanks.
Sure. Okay. So on this graph, if a score is positive, that means those who benefited most. For example, on the left panel, I'm plotting the beneficiaries from the wealth outcome. So if the score is positive, that means those who accumulated most asset, they were older than those who could not accumulate asset. For example, in terms of respondent age or primary beneficiary age, those who accumulated asset, they were older by 18 years. And if we summarize this graph, we see that at the individual level characteristics, those who benefited most on asset, they were older, they were relatively poorer because they were more involved in agricultural day labor and wage income, and they had lower participation in household decision making. When you look at the consumption outcome, we see just an opposite picture. Those who benefited most in terms of increasing their consumptions, they were younger, they were relatively less poor in the baseline because they had more involvement with self-employment activities and they had greater participation in their household decision making. And in terms of household level characteristics and community level characteristics, what we found is those who benefited most on asset, they're less likely to migrate out from their village. They had lower savings in the baseline and they were less connected to the market. And again, we see an opposite direction on those who benefited most in consumption. Then we also look at the same characteristics on those on our 2 more outcomes on savings and income. So the participants who benefited most in terms of accumulating savings, they closely match with those who also accumulated assets. But in terms of income, we did not find much heterogeneity, which implies that almost all the participants in the program had an uniform increase in their income, but some of them focused on asset accumulation and savings, while others focused on consumption.
So we have 30 seconds.
Oh, okay.
30 seconds.
Right. So the important takeaway from these findings is we find a trade-off between consumption and asset accumulation at the household level. And for the policy implications, we say that now that we know the households that are not likely to accumulate asset, what they should, and these are younger households who are most likely to migrate out from the village, and they have more involvement in self-employment activities at the baseline. What NGOs like BRAC and other policy makers should do is to introduce more intensive coaching for those kind of households so that they keep focused on asset accumulation. Or maybe graduation model may not be a good approach for them. Maybe a less costly approach like conditional or unconditional cash transfer program might be more effective for them. Thank you.
Great, thank you so much. And we'll encourage people to put your questions in the Q&A box instead of in the chat. So please put them in the Q&A box for Riyajul, but we're going to move to the next presenter, and Riyajul, you can take questions in the Q&A box, please. So we'll be moving on to John Proctor, who is a postdoc at the Harvard Data Science Initiative, having finished up his PhD in agricultural and resource economics at UC Berkeley in 2019. So John studies relationships that govern our climate and agricultural systems by pairing methods in econometrics, spatial statistics, and machine learning with global socio-environmental data sets. John's going to present work with SIGA affiliate Solomon Shang to improve the spatial resolution of UNDP's Human Development Index estimates by tapping into new data and methods. So John, I'll pass it over to you.
There we go. And then just need to. Sweet. Can you see the slides?
Yes, we can see them. Thanks.
Amazing. So thank you so much for this opportunity to share this work that's joint with partners both at UC Berkeley and UC Santa Barbara. And our work at a broad level has one central goal, which is to make it easier for people around the world to combine machine learning with satellite imagery to better understand conditions on the ground that they're interested in. And this is an exciting time to work in the space, given the recent explosion in available satellite imagery. Planet, for example, whose imagery we use in our work, takes a snapshot of the entire Earth every day at 3-meter resolution. And we believe, and has been mentioned many times in this seminar so far, that the information within the satellite imagery has the potential to improve human well-being. For example, by improving the efficiency of aid or social welfare programs, and by giving governments more information about their populations. The way that the unstructured information within satellite imagery is currently being turned into kind of structured measurements of conditions on the ground is that teams of experts from around the world, and predominantly in developed countries, produce high-resolution maps, such as the ones you see here, on variables like forest cover and deforestation, on poverty, or on population. And really one challenge here is that each measurement of a given variable is a major research enterprise and of huge value. But the progress has been limited to a small set of experts with the resources and domain knowledge to complete such projects. This leads us to believe that there's a lot of value within satellite imagery that's kind of being left on the table. So talking with colleagues, as well as people at statistical agencies around the world, such as the World Bank and the UNDP, we've met a lot of folks who would like to combine satellite imagery with machine learning to predict their own problems, but have been limited by the large barriers to entry in this space. Those barriers include access to satellite data, access to large-scale storage and computation, and access to machine learning expertise to translate the information within the imagery to actual conditions on the ground. And so to reduce these barriers to entry, we're working to develop a pipeline for multitask observation using satellite imagery and kitchen sinks. Kitchen sinks, the last word there is a bizarre name for the algorithm that we use to convert the actual image into usable information. So this whole pipeline here is called Mosaics. So how does Mosaics work? What is it? We begin with a set of imagery here on the left. And what we do is we convert the information within that imagery, so maybe what your eye can pick up, like roads and fields and streets, road density, that kind of thing, into summary statistics of each image. So a bunch of numbers that describe the information within each image. That table can then be stored and not touched again. And that's kind of a key element of this pipeline. We can then distribute these kind of summary statistics of the images to users who are interested in making predictions. For example, consider user 1 who has labels on forest cover in some regions and wants to make predictions in others. That user can merge their labels of forest cover with these summary of the images, run a simple regression model to learn the relationship between the information in the image to the conditions on the ground, and then make predictions in areas of interest. Another user could come along interested in population density. They collect labels on population density in areas that they have them. They link those observations to the pre-computed Mosaics features. They run a linear regression and then are able to make predictions in new areas. Importantly, this model here separates the complex task of embedding the images into a descriptive feature space, or essentially just pulling out the useful information from the images. It separates that complex task from the user experience, where all the users have to do is download these pre-computed features and use them to make predictions. An important element of this is that these descriptions of the image have to be flexible enough to work in a bunch of different settings. We've kind of tested this system through a bunch of different settings. So predicting forest cover, elevation, population density, nighttime lights, income per household, road length, and housing price in the US and also at a global scale. And we found that it performs quite well. And so what we're trying to do now is we are working to share this pipeline with the public, with the goal that its ability to work out of the box to solve new problems, its relative ease of use and its affordability. It's much kind of faster to run than competing machine learning approaches. And along with its competitive performance, our goal is to make combining satellite imagery with machine learning more globally accessible. And so if you're interested in learning a little bit more about how Mosaics works, I'd encourage you to check out one of our recent publications on the topic. We don't have time to get into the details here, but we go into all the kind of nuts and bolts of the method in that setting. We're working currently to create a publicly available and free API that folks who are interested in using these features to make predictions of their own are welcome to use. And this is kind of with support from SIGA as well. So thank you for that. And so if you're interested in exploring something like this or collaborating on a potential future project, please feel free to reach out. And so while sharing this pipeline with users, we've also found that some want to work with us to solve particularly challenging problems. And so one example of that is we're currently partnering with the United Nations Development Program to try to improve the spatial resolution of their Human Development Index. And so essentially what we're trying to do is we're trying to go from ground truth measurements at this ADM1 or state level at a global scale and improve that to ADM2 or county level measurements. So the Human Development Index, as many of you know, is one of the primary indicators of human well-being at the global scale. It measures not only income or standards of living, but also education and health. Its multidimensionality makes it an ideal application for Mosaics, which is designed to predict many things at low cost. The UNDP currently distributes the HDI at the national level, and recently a state level product was developed. And our goal is to now take this one step even finer to produce a county level product at the global scale using satellite imagery in the Mosaics pipeline. And so increasing the resolution of development indicators is important because, as Heriberto Tapia, our primary partner at the UNDP highlights, a primary goal of the development agenda is to leave no one behind. But the ability of many countries to track well-being at a fine spatial scale is limited. And so this falls in line with a lot of kind of the targeting narrative that's been discussed so far in this colloquium. So while I'm not going to get too into the weeds here, the key technical challenge is to make predictions at a finer resolution than the available training data. So we have training data at the state level, ADM1, and we're going to try to make predictions at the ADM2 and even finer level using the high resolution of the satellite imagery. We do a bunch of tests, both using measurements where we have high resolution, such as tree cover, to be able to kind of coarsen them and then try to train a model and then predict at finer resolution. We do a similar exercise with nighttime lights and with population, and generally we find that it performs quite well. We also test the ability of Mosaics to predict the Human Development Index itself, which is shown here, and we see that it captures a lot of the variation at the ADM1 level. And so kind of with that as support, we then turn to try to actually make a global map of the ADM2 level predictions. And so here you see on the top the map at the ADM1 level on the left and at the county level on the right. And we see blowups here for Africa, for Asia, and for South America. And so it's been a real pleasure working with Heriberto and his team. And I think we're all excited for this as a potential step towards a globally standardized and resolved system to increase the resolution of the Human Development Index. But in addition to working with Hero, it's been a very large team effort. Luke here Luke Sherman on the left here has been a huge contributor to the UNTP work, so just wanted to give him a shout out. So thank you so much, and I'm happy to take any questions as they come up.
Great, thank you so much, John. I think we have one open question in the Q&A from Diana about for how many and which years is this data available worldwide?
Yeah, so currently we only have a single global snapshot in 2009 available. We recently created a product that we'll share on the website soon, so look for that, which is able to create features using Sentinel data. And there you can create the features for any time period or any spatial extent that you want. So that's going to be a little bit more involved to access and implement. So right now, we have the features for the globe in 2019 processed and done. But for other time periods, there's the code to do so, but it's not, it would involve a little bit more expertise to actually run that yourself.
Great, and we have a question from Layla, who says this is far, far outside of my expertise, but could methods used for climate modeling downscaling be useful here?
That's a good question. I haven't done a lot of climate modeling downscaling. Essentially, the kind of intuition for why this specifically works at a high level is that we compute kind of these highly flexible nonlinear functions of the image pixels at a fine resolution and then aggregate them to the 1 kilometer level. And so those features then all contain the information in the image at that level. Then when we aggregate up to say the state level to make the predictions, we aggregate up all linearly and then run a linear regression. Because of that linearity, in the learning approach, kind of disaggregating to spatial, to finer spatial scales in a linear way is facilitated. If you're interested, that was a little opaque. If you're interested in more, we discuss it in the paper that I referenced earlier.
Great, thanks so much, John.
Cool.
Great. So thanks, John. Thanks, Brian, Carly, Rajul, and Christina for facilitating that second session and our first session as well.